Hey everybody, Jim here, and today I've got a treat for you. It's the Biselong 9 kilowatt instant water heater. The BIS, oops, sorry, let me get it in frame. BIS-09 9 kilowatt instant water heater. And boy, it looks pretty, but I'm gonna wait until I see what's inside. Boy, is that pretty. Looks like it comes with some instructions. And the instructions are in English, which is definitely a bonus because I don't want to learn more languages in order to install a tankless water heater. And look at that, it says it can be installed at any angle. Boy, is that a treat. The other ones, they all like to say they have to be mounted upright. Alright, it's just some instructions. Tells you about 220 to 240, 60 hertz, 9,000 watts, 40 amps. Maximum current, 40 amps. So it says 40 amps. Is that 9 kilowatts? Huh, maybe. So yes, technically 9 kilowatts is around 40 amps. That's pretty impressive. This thing's pretty heavy. I'm going to weigh it just to see how heavy it is. It looks like 8.8 pounds. It's just as heavy as the Ethereal 9K. Let's have a look inside. It's got a fun little rattle to it. Oh, I see there's some springs. Huh. Well, neat. Let's get in close. Alright, we're starting off here with the transformer. Got a kooky little fuse in there at 1 amp, 250 volts AC it says. I wonder what that fuse is for. Oh, looks like we've got 2 relays. The circuit board looks pretty clean and neat. I don't see any issues with it. The wiring seems a little anemic compared to the Ethereal. This doesn't look like 8 gauge wire. It looks closer to 10 gauge. But it's probably designed the way that, and engineered the way that they want it to be. So let's go a little further. It's got a lot going on with this control panel. This looks like it is for temperature, and it's only going to be in Celsius, it would appear. It's got a shower. Oh neat, it's got set Fahrenheit. So maybe it's, I don't know, Celsius and Fahrenheit with some sort of dial gauge. I don't know what's going on. I guess we'll look at it here in a minute. It's got some more information. I don't know what these are for. I guess I should RTFM Oh, and here's some more confusion. More Fahrenheit stuff. Standard, children, low flow, and ADJ flow. All quite interesting stuff. So it looks like it has... Ooh, looks like it's got 4 heating coils going into this keen rectangular kettle. Boy, is that pretty. And then the cabling coming in from this metal connector transitions into this plastic braided hose and then comes inside and connects here with a, looks like a 3/8 fitting. What an odd thing. 3/8 over here going out to the hot side. Fascinating. Yeah, they're definitely using pulse width modulation to fire these circuits. Oh, and that's going to be your 95 degrees Fahrenheit, sorry, 95 degrees Celsius quick disconnect for safety. Yeah, I don't know what these are for. What these Scooby little springs are. Oh, I see. These lights go right behind these buttons. So ADJ, high, power, low, funk. Neat. What else is going on in here? Not much. Got the pigtail going out to the side. Got these fun little shoelace crimp-on connectors. But I'm really, really grateful that they chose to go with metal on the connections so that when you put on your hoses, it doesn't snap them off. All pretty good stuff. I'll get the details for these, and they'll be in the video when we're watching it now. Yeah, let's get this hooked up. Sorry about the bouncing. Here are the wires coming from this Biselong, and here are the much bigger wires coming out of the ethereal that really seem like they're at 8 gauge. These look like 8 gauge wires. These don't look like they're 8 gauge. These look much closer to 10. I suppose I should reassemble this. That's pretty neat. The design of the clamshell case is such that the front cover is a couple of millimeters shorter here in the back than the back cover. And so when the back cover is installed, it's under constant tension. Well, I don't much care for the fact that the NPT connectors are obfuscated by this cover. I have to reach under there with the pliers in order to give them that last quarter turn past hand tight. Alright, let's evacuate the air. Let's charge it and then evacuate the air. Nice. Oh, my poor old braided hose has a 8-year-old rubber washer there at the end that's dried out and is not holding a good seal, but I'm not too worried about it. This is just a test rig. Alright, let's evacuate the air. It looks like the water coming out of the ground is right at 68.7. Let's see how hot this device can make the water. Pretty. There's a lot going on there for a second. Let's see if what happens when I turn this on. Wow, a lot. Let me peel this protective layer off of it. Oops, I touched something. Okay, so it claims that it's 22 degrees Celsius now. And, let's see, it's set to Fahrenheit 102. I want to go a little higher than that. Let's figure this out. So these look like they are heat-sensitive buttons, because there's nothing but plastic underneath this shell, and there's no sensors under here. So that's probably what the springs were. Sensors to see if you're actually touching this. Neat. Oh, let me RTFM. I'll be right back. All right. It turns out that it's actually pretty intuitive. There are these ADJ, or adjust buttons, and the function button, and then of course low and high, and then power. They do a lot of different things. I'll try to go through them quickly. To adjust the outbound temperature, and boy, this is another fun thing it does. After about 2 minutes, the screen just goes blank, except for this Fahrenheit symbol. So you have to come here and poke around until you find the power button. There it is. So in order to adjust the temperature output, you hit adjust, and then you raise it as much as you like. I think this, I don't know how high this will go. Let's find out. Oh, it looks like it's capped at 131, like a lot of them, 55 degrees Celsius. And it shows it here again. So you have two where it shows you the setting in Fahrenheit. That's neat. So right now it shows you the, I guess is the out temperature currently in the kettle where the sensor is. I want to hope that that sensor is right here on this on this hot outlet and not on the kettle. Same here. 21 degrees Celsius is the same as 69. If you come here again and you hit adjust, you can actually go through a couple of things. If you hit adjust again, there's spring, summer, and winter, and then all of them selected at the same time, which makes me think that the whole thing is moot. Oh. And for whatever reason, when you touch that button, look at that. It drops it down to whatever it thinks is a good temperature for spring, summer, or winter. That's really an unnecessary feature if you ask me, but it's there. Additionally, over here you can switch between normal and child mode, and it looks like children mode just puts you at caps it at 100 degrees Fahrenheit or 38 degrees Celsius. If you hit it again, it stays in children mode. If you hit it again, it goes to standard mode. Children, so there's 2 children modes and a standard mode. I'm going to leave it there. I'm going to pump this back up again to 55 degrees because I want to do a test to see if it'll produce from 60, oh, I forget how hot the water was coming out of the ground, but probably around 68.5 degrees. 67.5 or 68.5. I'll write it here on the screen somewhere. I want to make sure that it'll get up to 131 degrees Fahrenheit, drawing 9,000 watts. You know, I'm really looking over here. This is my 8 gauge wire, which is hot right now. Let me take my finger out of the box. But you see the hot wires coming in from the panel over there, and that's 8 gauge. This wire is definitely not 8 gauge. This looks like 10 gauge at best. That's really troubling me, but that's how they designed it and that's how it arrived. Let's continue on with the test. That is hot. Yeah, it shouldn't be putting out 66 degree or 149 degree water. That's actually pretty unsafe. I think it was just for a second. Now it's really fluctuating. I don't know if I like that. This may be an issue with the system doing pulse width modulation using relays instead of MOSFETs or triacs. But boy, you see it fluctuating a lot. Ooh, I don't care for that. That's gonna cost it some points. Over here it's drawing 37 amps. 35. So it's... Oh, there it goes. That's weird. For a second there, it stopped drawing any amps at all. I heard a clicking noise and then it stopped. And then I heard another clicking noise, and it started. Oh, there it is again. Look, it went to 0, 0. So, I suspect that the thermostat inside is detecting 95 degree water and just kicking it off. And then it kicks it back on once the water is temperature is low enough inside that kettle. Neat. Alright, just for this test, I'm going to see just how hot this water is. And I believe it. I believe it's between 55 and 65 degrees, but we're going to find out. Alright, it's... There we go. 122, 124, 132, 133. Oh, I don't like that. It's fluctuating 10 degrees Fahrenheit. 124. Okay, so this is really just a stress test to see how many amps the thing, or how many watts it will pull. And it looks like it's capping out at 36 amps. Maybe on a colder day, when the water comes from the ground at a colder temperature, the thermostat won't kick it off. If the water's coming out of the ground 20 or 30 or even 40 degrees colder than the 70 degrees that we have here, then it's going to use a lot more electricity in order to heat up that water. Let's see what it does at 113 degrees Fahrenheit. Oh, neat. I don't have to hit adjust in order to drop the temperature. Alright, so 45 or 113 degrees Fahrenheit will get you a nice hot shower. and not burn up your children. That's a good safe temperature. So if you're operating one of these Keen tankless systems at home, aim for around 113 degrees. That's really safe. Oh, that is not good. Oh, all right, let's see what E4 is. The surface temperature is over 149 degrees Fahrenheit. Right there. I'll get that in close for you. E4. Automatic recovery when it drops to 110 degrees Fahrenheit. Okay, so yeah, it was just too hot. When I stop the water in there, the coils are still very hot, so it just keeps heating up that water after the system is shut off. So it seems much happier producing 45 degrees Celsius water. It's, for whatever reason, 47 and not 45 where I had it set. I guess it just can't do 45. Let's see just how hot this water is. I have to aim you back down at the faucet. I'd say that's pretty close. I think I'm ready to make a decision on this Keen device. I wanted to tease this open and get a closer look at it, because I still had to get the part numbers for these relays and for the flow sensor, which I think are already in the video. I couldn't figure out what this device is. There's no model number on it, but I'm pretty sure it's a 95-degree quick disconnect that opens and cuts the electricity to the entire device whenever it hits 95. You'll see that the two hots come in and they hit this relay, and then everything in this appliance is downstream from this kill switch. So you see the blue wires, they come down here and they hit the PCB, and there's another wire that comes from the PCB and then goes back up to the top of the kettle. So I can't see the inside of this aluminum kettle, but it looks like there are 1, 2, 3, 4 heating elements that go in a horseshoe shape through the thing and then come back out over here. That just seems to make the most sense. You can see how these pairs are wired separately, and you have the silicone gel in there, high temperature silicone. There is, from these two relays, one really beefy wire that runs over to here into this one, which I'm guessing is going to be connected, I have to guess, comes out of here, goes back to this blue wire, which runs down to this PC board. Okay, so alright, so it looks like the one end of each of these is connected to these blue wires that go down to this PC board, and then these two wires go off to these two relays and are wired here and here. Yeah, it's a little cumbersome. So yeah, everything's downstream of this device. So if it was hitting 95 degrees, the display should have blacked out. and gotten no electricity. But that's not what was happening. Something else is happening. One of these relays was firing and shutting off the kettle because the logic has it set so that if it exceeds 40 degrees or so inside the kettle, it automatically shuts off and waits a moment for the incoming cold water to drop the temperature. So it's really not designed to run that water at 131 degrees Fahrenheit, and let's be realistic, you never want to run your water heater at 131 degrees Fahrenheit. That's going to burn your children and yourself. Just don't do that. Very odd. Got your typical donut here that measures the amperage coming in, and so that's going here into the circuit board. That could have been it. It could have been hitting 37 amps and deciding, hey, I'm drawing 37 amps. That's too much. Let me just stop for a moment. But I really want to believe that there is a temperature sensor in here that reports up to the board here that tells it the water's coming out too hot. Shut off. That would make the most sense. So yeah, these relays, they're not bad. They're made by Songle. I'd never heard of them. The rest of the board looks great. Yeah, alright, let's get back to the review. Alright, that's pretty good. Boy, I tell ya, this device is huge. And unlike the Ethereal, which was mostly empty space, there's a lot going on inside of this. I don't know how I feel about the rubber hoses inside, with the plastic gray braiding, but whoever designed it that way and said, hey, let's just make it that way. It is enormous. It's just as big as the Ethereal, if not bigger, but what you gonna do? This lip, it's not that big of a deal that it obfuscates the two connectors here. But I think somebody really wanted to make this very aesthetic, and they succeeded. I don't know that I care for this weird Fahrenheit dial. I like that there's Celsius and Fahrenheit, but I think it could have been done just as well with either or. This is very silly. It doesn't do much. The child thing is not necessary because you can set the thing at 100 degrees Fahrenheit if you want. I think there's just too much going on in this panel. One thing I'd love to see is some way to find this power button. I got half a mind to take a Sharpie and just write a circle around it so that when the display powers off, I can still find the power button. Let's talk about price for a second. This appliance costs $130 at the internet big box store that everybody buys their things at, and maybe a little bit more at other websites. But for $130, you get an appliance that will heat your water, looks like about 67 degrees Fahrenheit at a flow rate of 1.5 gallons. It'll heat it up a lot more at a rate that's slower. So definitely consider this device if you live south of I-10 or south of the 30th parallel. If you're in a latitude that's south of 30, then this device will work out just fine for you. If you live south of I-20, then you may have to restrict the flow to get a nice hot shower in those cold winter months when the water comes out of the ground below 50 or below 40. Just a thought. As you can see now, there's no way to find the power button. You just kind of have to know where it is. You can poke around for a while and eventually find it. Maybe one of these other buttons. Oh, the other buttons do activate it. So if you wander around with your finger, eventually you'll find one of these buttons and get the thing to turn back on. Yeah, I like the device. I think that where is it? Here it is. I think that this Kunios does the same thing. If this one's pulling 67 amps, that's the most I ever saw it pull, but that could be because the differential between the cold water in mid-March and the 131 degree Fahrenheit cap that this machine is willing to do isn't enough to draw that whole 40 amps that it claims. But this device will do a 36 amp draw. Wow, did I say 60 amps? Or 60 degrees Fahrenheit? That's not even close to right. Let me correct myself. This thing claims it'll do a 40 amp draw, or 9,000 watts, and the most we saw it was 36 amps. That means at a flow rate of 1.5 gallons per minute, your Fahrenheit rise in temperature will be 37, or alternatively 40 if the thing actually draws 40 amps. So yeah, it'll work fine for you south of I-10, where the water comes out of the ground at 60 degrees around Pensacola for the winter months. In the coldest winter months, that water's coming out of the ground at 60 degrees. And if this device can add 40 degrees to that, that'll get you a 100-degree shower most of the year. Right now it's coming out of the ground at almost 70, so if it adds 40 to 70, you get a 110-degree shower. That's at a flow rate of 1.5 gallons. If your flow rate is a little bit less, 1.25 or 1 gallon per minute in one of these low-flow shower heads, then yes, you'll get a rise of 50 or even 60 degrees from this appliance. But this device does this Kunios for about $100, and for half the size, yeah, that's like half. Let me get back up. Right, you have to go way back in order to get the whole device inside the camera's field of view. But all told, I like it. It's very pretty. I like that I can mount it sideways. And for $130, you really can't go wrong. It's got those 2 relays in there that are controlling the 4 heating coils, and I don't see any problem with that. If each one's rated for 30 amps, then together that's technically 60 amps. So if it's drawing 36, it's probably way overrated for what it's designed to do. It keeps the temperature very level. It's only off by 1 degree, and it only fluctuates a little bit. So I'm really satisfied with the temperature of the water as it's coming out. The size, not so much. Still, for $130, you can't go wrong. Well, I sure learned a lot making this video, and I hope you did too. Thanks so much for watching.